Hello and welcome to the YouTube channel D Creations Resources. We are looking at different aspects of spectroscopy, and today let us talk about the principle of infrared spectroscopy or IR spectroscopy. Now, infrared or IR, as it is referred to, is basically an electromagnetic radiation with its wavelength regime between around 780 nanometer to around 1 millimeter. And as you know, its position is between visible and microwave electromagnetic radiation. It can be divided in different regions such as near infrared, mid infrared, far infrared, etc. Out of which near infrared will have the least wavelength, then mid infrared, and far infrared will have the highest wavelength corresponding to infrared. Now, of course, you can calculate the corresponding frequencies also, so which they would be few hundreds of gigahertz to few hundreds of terahertz. Now, in infrared spectroscopy, we are analyzing how molecules are absorbing infrared light and then revealing information about their structure and vibrations, especially the stretching and bending of bonds, etc. Now, depending on the structure of the molecules, they vibrate at specific frequencies. And these vibrations correspond to certain regions of the infrared spectrum. So, when a molecule absorbs infrared light, the energy of this infrared light excites these vibrational modes, causing the atoms to move and vibrate. Of course, not all kinds of molecules can be subjected to IR spectroscopy because, as the term goes, not all of them are IR active. Now, for a molecule to absorb infrared radiation, the vibrations must cause a change in the molecule's overall dipole moment. Now, what is dipole moment? Dipole moment is a measure of how separated the opposite charges are within a molecule or a system. It's a vector quantity, and if you want to calculate it, you need to take the product of the charge and the distance which is between the charges. So suppose charge is q, and if the distance between the charges is denoted as d, then q into d is going to give you the dipole moment. And so the unit is also straightforward. Unit of charge is coulomb and unit of distance is meter, so the unit will be coulomb meter. There is another unit called dBi. 1 dBi equals to 3.33 into 10 raised to minus 30 coulomb meter. So there are some molecules which are IR active while some molecules which are IR inactive. Now, a homonuclear diatomic molecule, say O2 or N2, so basically two oxygen atoms or two nitrogen atoms. Now here these are going to be IR inactive, but a molecule like water which has a dipole moment because of the shape it has and also the lone pairs of electrons is going to be IR active. Similarly, HCl, hydrochloric acid, is an IR active molecule. Now, an important aspect of IR spectroscopy is that it is able to identify functional group. What are functional groups? Functional groups are specific groupings of atoms within molecules which have their own characteristic properties, regardless of the other atoms present in the molecule. So, to give you a simple example, when you say ROH, you know that you are talking about an alcohol. So, suppose if it is methyl alcohol, it is CH3OH. If it is ethyl alcohol, it is CH3CH2OH. But this OH is basically the functional group for an alcohol. So basically each molecule is going to produce a unique infrared spectrum, and you can also call it as a molecular fingerprint. It's a signature, and you are able to identify and characterize unknown compounds by comparing their IR spectrum with the already available IR spectra. So basically, A molecule will absorb infrared light when the frequency of the infrared light matches the vibrational frequency of the molecule. And this absorption of infrared light will create a unique spectral fingerprint for each molecule.